Hi, and welcome to Lesson 2 Annuities. This is in Unit 3. It's Unit 4 of Apex, but it's really Unit 3 in our class. All right, so you learned yesterday about some annuities using one of those methods, either the Quizlet, the reading, or the video. So today we're going to perform some calculations on these annuities. All right, remember we can invest in an annuity in two different ways. One is with a single payment. The other way is with reoccurring payments, making several payments throughout your life, either monthly payments, weekly payments, could be yearly payments. That would be a recurring payment, similar to like a 401k that you may have heard of. A single payment one acts like a CD, with one exception. The growth is tax deferred, which means you don't need to pay taxes on it until you actually withdraw the money. All right, so let's first talk about a single payment one, since that's one that we are familiar with. Again, works just like a CD, so we're going to use our future value formula if we want to know the future value of it. Again, here is the formula. Remember, P is the principal, or the original amount. R is the periodic interest rate, and again, be careful. Make sure you're changing that APR into the periodic interest rate by dividing by the number of periods. And T is the number of compounding periods. All right, so let's try one here. After 10 years, what is the value of an annuity in which you invest $10,000 at an APR of 4%? Assume the interest is compounded annually. All right, where our principal is $10,000. Our interest rate, 4% divided by 1. Since it is compounded annually, it's compounded one time per year. And N would be 10. There are 10 times that this is going to be compounded, since it is 10 years. So if we plug that into our formula, we would find that after 10 years, our annuity would be worth $14,802.44. All right, your turn. Try this single payment annuity. How much is an annuity worth after 5 years if you invested $2,000, got an interest rate of 3.9%, and compounded quarterly? Be careful, compounded quarterly. All right, so let's see what you got. Hopefully it matches what I got. Notice the interest rate there, 0.039 is being divided by 4. Since it's quarterly, 4 times a year, the number of periods would be 20. 4 times 5, 20 times. All right, for a future value of $2,428.33. All right, so that was, again, a single payment one. We've done those with the CD, so we're pretty comfortable with those. Calculating the future payment of one that is a recurring payment, it's a little bit more complicated because the money isn't being invested all at once. You're continually adding to it, and we call these periodic contributions. So let's examine this. Suppose we invest $60 a month in an annuity with an interest rate of R. What is the future value of the account after 1 month? Well, if we think about that for a minute. After 1 month, the value of it would be $60. That's the original amount we put in there. 1 plus the interest rate raised to the first power. That's the old future value formula. So that's how much it would be worth after 1 month. What about at the beginning of the second month? We're again going to put another $60 in there. What is the future value of our account? So think about that for a minute. All right. The future value of the account is going to be this amount plus another $60. To get the answer, we're simply adding $60 to our last answer because you're adding $60 into the account. And that's the beginning of the month. After month 2, how much is your account worth? This time we're adding in the interest. Adding to that second month's investment, there we go. You can see there at the bottom, we invested another $60, so add that to the following. You can see there's the interest for the first month, the second month, and the initial $60. That's going to lead us to this periodic investment formula, because you can see doing that is going to get very huge if you keep doing that every month. Luckily, we have a shortcut, a wonderful formula called periodic investment formula. It puts together this pattern, and it's actually a geometric series, if you remember those from algebra. It's a geometric series. Here is the formula. Again, P is the monthly payment. R is the interest rate. Again, periodic or monthly interest rate. And N is the number of payments made. So let's practice using this formula. All right, suppose we're investing again $60 a month in an annuity. This time it's earning 10% interest. What will it be worth after 2 years? Well, if we look at this, the principal is 60. The interest rate, notice it says 10% interest monthly, so 10% is our interest rate. Number of payments, this is 2 years, so there should be 24 payments. There you go, the future value of that $60, putting $60 a month in an annuity, after 2 years will be worth $5,309.84. And you can see here exactly how you would put it into the calculator, making sure you have your brackets and your parentheses correct so that it knows what to keep together and what to raise to an exponent. So be very careful when you do these in your calculator. Go ahead and try this one. Monica here, investing $75 a month in an annuity that earns 4% APR, compounded monthly. Notice that is 4% APR, so change it to the monthly interest rate. What is the future value of the account in 5 years? All right, here is the answer. Notice again, we took that 4% and we divided by 12. All right, try this one. Ross here, investing $150 a month in an annuity that earns 6.5% APR, compounding monthly. What is the future value of this account in 3 years? All right, hopefully you had a chance to do that one. There it is. Again, I think the hardest part is putting this into your calculator, so please pay attention to the parentheses and the brackets so that you got them all in there. All right, we'll try this last one here. We've got David investing $200 a month in an annuity that earns 3.9% APR. All right, there is the answer for David. All right, now that you've practiced those, again, we notice the annuity, similar to that certificate of deposit, you need to keep your money in there. If you take it out earlier than you should, you're going to get what's called surrender charges, or charges by both the IRS and the lending company. Now, a lot of times a lending company with an annuity is an insurance company. So both the IRS and the insurance company can charge you fees for taking the money out too soon. So let's practice calculating these. Suppose we want to invest $50,000 at age 35 and we do agree to start receiving payments at age 40. So we agreed with the insurance company that we're going to receive payments at age 40. At age 37, for some reason, we decided to withdraw $5,000. What is the IRS fee? Now notice up at the top there, remember the IRS is going to charge 10% if you withdraw your money before you are 59.5 years of age. So To calculate the IRS fee, you would find 10% of $5,000, which would be $500. That would be the IRS fee. Now the insurance company is going to penalize you $60,000. I'm sorry, not 60,000, 60% because you withdrew it before age 40. So what is the surrender charge? Similar, we're going to do 60% of 5,000 and find out that it is $3,000. That would be the penalty that you would have to pay the insurance company. How much would you be penalized in total? Remember, it was $500 from the IRS, $3,000 from the insurance company. So the total fee, $3,500. Your turn. Try this one. Alrighty. So we're withdrawing $10,000. The IRS fee is going to be 10% of that, or $1,000. The insurance company is also going to charge the 10% of the $10,000 withdrawal. So you can see there is the surrender fee for the insurance company. See if you can find the total amount that you will be penalized. Yep, $2,000. All right, your homework is to complete the Unit 3 Lesson 1 quiz. Remember, there are extra practice problems for you on the Unit 3 guided notes. The answers will be in our folder if you need them.